Hello everyone, and welcome to CSPTek. Today, we will introduce the CW, or Continuous Wave, option in VSTCore for SDRs. This is a cross-platform solution designed for software-defined radios, providing a unified and efficient development environment for a wide range of wireless testing scenarios. In complex RF system development, having a stable and controllable reference signal is essential. However, traditional testing workflows often involve complicated hardware integration, fragmented user interfaces, and inconsistent instrument settings. These challenges reduce validation efficiency and may also introduce additional system-level errors. So, what is CW? Simply put, CW is a waveform with constant amplitude, fixed frequency, and continuous transmission over time. From a mathematical perspective, it has a single frequency, continuous phase, and stable average power output. Because of these characteristics, CW is one of the most fundamental reference signals for RF calibration, hardware validation, and system measurement. When we compare CW with pulsed waveforms or FMCW, its characteristics become very clear. CW has an extremely narrow spectrum with highly concentrated energy, which gives it excellent signal purity. Although it does not provide direct time markers for ranging like pulsed signals, CW is highly valuable for speed measurement, carrier verification, and interferometric measurements. To address the integration challenges in traditional RF development, CSPTek VSTCore provides a unified operating framework. It connects signal theory from the academic side with industrial-grade hardware validation. Through a single interface, users can generate, receive, and analyze CW signals in real time, ensuring that the entire development process starts from a clean and stable reference signal. In the following demonstration, we use the USRP B210 for self-transmit and self-receive validation. In this setup, the same SDR platform is used to transmit the CW signal and receive it for analysis. The workflow includes hardware initialization, parameter configuration, continuous transmission, and real-time receive-side analysis, forming a complete RF validation loop. The first step is hardware initialization. In the VSTCore interface, users only need to select the SDR platform, enter the device serial number or connection IP, and click Initialize. The system then automatically completes the hardware connection and handshake process. This reduces manual setup effort and allows testing to move quickly into the validation stage. Once initialization is successful, the corresponding function buttons will be enabled. By clicking CW, users can open the dedicated CW operation window. This interface integrates both VSG, or signal generation, and VSA, or vector signal analysis, into one workflow. In other words, functions that used to be spread across multiple instruments are now combined in a single operating environment. Next, we configure the key parameters. Users can define the center frequency, sample rate, capture duration, and other measurement conditions. After the setup is complete, simply click Run. The SDR will immediately begin generating and transmitting the CW signal, while the VSA interface receives and analyzes the baseline tone at the same time. In the PVT, or power versus time, plot, we can observe how signal power changes over time. For an ideal CW signal, the trace should appear as a very stable horizontal line. This means the power remains consistent throughout the capture window, with no obvious fluctuation. This level of stability is the foundation for accurate power calibration and hardware validation. Next, we switch to the PSD, or power spectral density, plot. An ideal CW signal should appear as a single, narrow, and high-energy spectral peak. This allows engineers to quickly confirm whether the signal is located at the correct frequency, and also check for frequency offset, phase noise, or unwanted interference. It is a key tool for evaluating signal purity. In addition to visual plots, VSTCore also provides real-time numerical feedback. Users can directly confirm the received power level and quantify CFO, or carrier frequency offset. This information is critical in RF systems because it helps identify clock mismatch between the transmitter and receiver, enabling more accurate system calibration. The VSTCore CW option can be applied in many different environments. For academic users, it provides a low barrier and easy-to-use SDR experiment platform. For system integrators, it can accelerate instrument calibration, IQ validation, and debugging of complex RF systems. With a unified tool, the development workflow becomes more consistent and the validation cycle can be significantly shortened. To conclude, every complex RF system begins with a stable reference signal. CSPTek VSTCore transforms the traditionally tedious CW testing process into a workflow that is more intuitive, efficient, and repeatable. With this tool, we hope to help you simplify development through more precise validation and measurement. Thank you for listening.